This conference will now be recorded.
Hello friends, welcome back. Welcome to the next session. Apologies for a little delay. I just had to restart my machine and had a little problems. And I will start the class. I just want to check if you guys are able to hear my voice properly and you're able to see the screen.
Yes. Yes.
So yesterday we were discussing about the different applications of data science and we are able to understand about what is the difference between data science and machine learning and artificial intelligence and so on. Today, what I was thinking is we will try to go through a whiteboard session where I will be taking you through multiple phases of the data science life cycle, right? So, let me request everybody to go on mute, please. So there is no disturbance in the background. Thank you. Generally, I use this sketchbook, which is more like a whiteboarding session. I can draw something, and you would be able to see this anything which I would be explaining. So you can say end-to-end data science life cycle. So initially, what happened was people were collecting data. They were collecting data for some analysis, and the data they used to store in databases. Now, this is like we are taking a little history about how the data analysis and all that thing happened. So people used to collect data. This could be your regular, retail companies or banking companies or healthcare. You can take any companies. So they what they are doing is they are taking data, and that data is stored in databases. So initially, when they wanted to start with analysis, the first kind of analysis which they started is called as descriptive analysis. Now, what is descriptive analysis? Descriptive analysis talks about now if I collect data, it is already there. So then what I would do is I will try to explain the data. Now, what is the explanation of the data? I will say like how many vehicles in for a particular car company are sold in the month of January or February or March. So when I'm trying to do that, I'm trying to explain the maybe the count of the number of vehicles, or probably I will try to take average or find out minimum or maximum. So all these things So all these things comes under something called as descriptive analytics. Now, descriptive analytics is basically you try to run some of these basic functions so that you can get your counts and information and so on. And then based on that information, people will try to take some decisions. Now, looking at it, they are directly stored in the databases. So what people used to do for running the descriptive analytics is they used to run SQL queries. Now I can write an SQL query like select star from so and so table where the customer is greater than so and so, and so I can write some SQL queries. I hope everybody is aware about what is an SQL. So SQL is a SQL query language where we are trying to talk to the databases directly. Now these databases could be Oracle databases as MySQL or Postgres or DB2. So any of these databases where you would be writing the queries and you would be retrieving that information. So initial days, people used to start with that kind of analysis where data is stored in the databases, the front-end systems, and the front-end systems used to store in the databases, and they used to call this as ODS. ODS is operational data stores. They used to call them as ODS, which are called as operational data stores, the primary databases where the data is stored. So they used to run the queries on the primary databases to find out the numbers. So to find out the description of the data, descriptive analytics, all those things to find out, they used to query these databases. Now, when the business is running and they are querying the database, there used to be a bottleneck. Now, what is a bottleneck? For example, somebody is doing business, like say a retail company, somebody is buying some groceries or something like that. At the same time, in the back end, you are running a huge job, right? A job is basically trying to understand how many packets of oil are sold in this month. So when you're trying to get that kind of analytical information, how many bags of how many packets of oil are sold in this month, then what happens is it actually slows down your process. So the front end of systems, like the people who are working on the projects, who are working on the real world, actually they were getting lags. Basically my jobs are interfering with the SLAs or basic access points of your users. So because of that, people decided that because they are getting because they are building problems, because they are getting lags, then let us not use these jobs. Let us not run these queries while the business is active. So the first step, what they did was they shifted the running of the jobs from the morning time to the night time. All right. So initially what they used to do, business used to run, and they used to run the queries in the morning time itself where the business is running. But what happened was, because that is causing interference with the actual working, and the users are getting delays and so on, the analysts, what they did is they shifted from morning to the evening. Now when the data jobs have shifted to the evening, they are called as nightly jobs. Okay, so the nightly jobs, what they do, I'll write it here, nightly. So the same jobs, but instead of morning, they used to run in the night. Now, what are these same jobs? Maybe like trying to find out how many kgs of sugar were sold in the month of, say July or August and so on. So those nightly jobs, what they used to do is they basically used to run in the night, and then this used to work for many years. So many years they were not having problem, because in the morning time, the business is running. In the night time, where there is no business and everything is in a halt, these bad jobs are running in the night to get some analytical information. Slowly, the adoption of internet and the expansion of the economy and global presence and so on what happened is these companies are now globally available, right? Initially, they used to be only in US or maybe in Australia or maybe in Singapore or Dubai. So they used to be only limited to a specific countries. So, this time zone was not a big problem. But what happened is slowly the companies have started working on multiple, areas or multiple geographies, and because of the penetration of internet, what happened is everybody, is trying to book things irrespective of the time zone, right? So people were having access to the websites, so they created websites for doing the same shopping what they used to do in a regular shop or a mall, and because of that they no longer has to come to the shop or a mall, and then they go to website and they book it. And also mobile revolution came and so on. So what happened is instead of the nightly jobs, because there is nothing like a nightly job now, because if it is a night in US, it will be day in Australia or Singapore or India or Dubai. If it is night in India, then it could be day in UK or some other place, right? So you're getting. So what we are seeing is there is no kind of a hotspot where we can say that okay, this is the right time to run my jobs. So that was never used to happen. Now that has actually created an entry to something what we call as a data warehousing systems, right? So that is the place when people thought that, okay, let us not run these jobs, which are like long pending jobs on the databases. We will quickly run the jobs which will do dumps. Now, what are the dumps? We will try to identify a time zone where it is having a minimal impact and then dump the data into a data warehousing system. Now, what is a data warehousing system? Now, data warehousing system is nothing but a similar kind of a typical databases which have more capacities of storages and so on, and they will be having an ability to store multi-year data, old data, multi-year data, right? Now regular or ODSS, what we'll have is operational data stores is real time. That means that as of today, what is happening, that information will be there. It will not have an ability to store like what happened yesterday, what happened 1 week back, what happened 1 year back. That information will not be there. The operational data stores will only have the current information as of now, as of today, what is happening, how many transactions happened, or whatever it is there, that will be available. But if the prices changes or anything happens, all those things, patterns changes, all those things will not be captured. So what these ODSs uh, are being dumped into something called as data warehouses. The process of dumping this is called as ETL. You might have heard about this, you might be working on this also, but if you know all these things, please bear with me. So the process in which this dumping happened was called as ETL. It's called as extract, transform and load. Extract, transform and load. In sense, extract is the extraction, it's more like a dump kind of a stuff, or you would take a loading from your operational data stores to a file system and file system to data warehousing. So, or you can directly load it with the data warehousing. So that is the extraction step. Transformation is also a process in which while doing the extraction, you would like to do some mappings. You would like to say like, okay, I would like to get these data from this files, these data from this tables. I would like to do some join, removal of columns, transformation. So there are multiple types of transformations which are available. So all those kind of transformation can be done while the data is getting loaded. All right. So ETL, it's called as extract, transform and load, where you will load the data from the real databases to the data warehousing databases. Now, so far so good, everything is good. So advantages of databases is when you have huge amount of data and there is a requirement for storing uh, multi-year data, data for a huge past, and we want to store it for a longer period of time, you can use data warehouses, And then when you have the data, you could do a lot of analysis. You could do change data capture. You can identify what happened last month, last year, 10 years back. Like that, you could do a lot of comparative analysis. You can run the jobs because now these data warehouses are decoupled from the actual databases. So if I am running long pending jobs, that means that jobs which are running for a longer period of time. It might run for 1 hour, 2 hour, 5 hours. It doesn't matter. It is not hampering your ODSs. Are you following? So when they are not hampering your ODSs, it doesn't matter. So you can run these jobs for a longer period of time, and you would be getting the results. So a lot of data analytics jobs used to run in this manner, right? So once I run the jobs, I can also create some reports. I can also create some views, like to view your data or present a report and something like that. So all those things can be done here. No, so far so good. Things are very, very nice, right? So we are able to run these ETL, and this kind of thing actually ran for many years. I know early 2000s where data warehousing started, and it is now, even nowadays we are still using data warehouses because a lot of business has this kind of an approach. So they have invested heavily in many of the proprietary tools. They have huge amount of data processes and all, so they are still continuing this kind of a process. But what they observed is, instead of, so this will be primarily the business data. So what is the business data? The business data would be regular transactional data, uh, whatever has happened, right? So regular transaction data is falling into this business kind of an approach. Now, what they have identified is, apart from this regular business, they're also getting some other kind of data. Businesses has grown from what they were before, but now they are trying to get more data. So what is this more data they are trying to get? Getting data from, say, file systems. They're getting data from some flat files, maybe some mainframe systems are there, or some other kind of systems. I would just say mainframes. Now, mainframes are old systems where most of the data is stored in the file-based format. Then you have log data. Now, that could be logs. So what are the logs? That could be system logs. There could be operational logs. Understood? So different types of data is there. You are also, so what they did is, because we are having so much different types of information, now let us not use data warehousing. We will create something called as, we try to use another color. So we created something called as a data lake. So we created something called as a data lake. Now let me write it here. Now, what is a data lake? Data lake is nothing but a storage place where we can store huge amount of data. That could be data coming from the mainframe files, that could be data coming from the log systems, clickstream logs, system logs, operational logs. The data could be in the form of video, images, like I'm trying to draw some image. Some mountains and river and so on. So the video can be coming from images, or data could be images or videos or any other type of data. Data can also come from some sensors. So what this says is now the data is no longer coming from an ODS, operational data stores. They are still getting the data from that ODS. So they will still continue to have this kind of a common central system. But apart from that, we are also getting some files. We are also getting from log data, some real-time streaming data, clickstream data. You're getting images, videos, text files. You're getting sensor information from IoT devices and so on. Now the world has grown beyond the single data sources, and they would need to have a storage ability to store the data beyond your normal database. And when that happened, now they created something called as data lakes. And the data lake, what is it? A data lake. So this can be a common file system, or typically you might have heard like big data. It is comprising of big data or Hadoop storage system, or you can use some of the cloud providers like AWS S3, Azure Blob Storage, or anything. I'm just writing Azure and AWS. You could use other ones also. Understood? So what does this data lake comprises of? This is a system in which we are providing huge amount of storage. Now this will have the same files and all that stuff. Whatever we are representing, we are also having database kind of representation. We also have files and log data, sensor data, images. We will have ability to store everything. We will have ability to store every information, and it can be considered for our analysis. Now there is a lot of work here which is involved. So this entire gamut of technologies which are storing all this data. Now it could be log-based data, so you would be using things like here getting your files onto your systems. You will be using things like Flume. Here we would be using something like Kafka, where you are getting some log information, real-time streaming information. All that information will be pushed into different systems. They might be using something like Kafka. Images and videos, again, you could use something like Flume or another kind of connecting systems. You could use some of the cloud providers connecting systems like Kinesis and things like that. So you would use multiple systems, and the storage information can be used using an ingestion tool called a Sqoop, where this sensor information will be in some input databases. So you would be using Sqoop for putting the databases into your data lakes, right? So here you are seeing a lot of technologies, and for the storage also you would use Hadoop or some cloud-based technologies and so on. So this entire stack of information or stack of work will be falling under something called as data engineering. All right, so this entire section falls under something called as data engineering, where you have a responsibility to set up systems where the data will be fed into your data lakes, and you could do the storage for a longer duration of time irrespective of the type of the data. So it could be a log data, it could be an image, it could be a text file, it could be a sensor information or an information from the business. Okay, so all the data will be fed into the systems, and this entire section is called as data engineering. So once the data engineering is done, what we do is we try to create something like a section where we call as exploratory data analysis. can create a small box here. It is called as exploratory data analysis. Now, what is exploratory data analysis? So once I have the data in the systems, now I kept the data into some Hadoop system or an S3 storage. So we understood that, okay, we need this responsibility of getting the files. So we got the files here and I have kept the information. Now, once I got the information, what we try to do is you try to understand what the data is. Now, when you get the information from the front end systems, entire information might not be required, right? You might not require the entire information, you only require some part of the information. So in such cases, what you try to do is you try to do some basic analysis. So you try to say that, okay, let us only collect these columns. I would not use all the columns. I would only use the first column, eighth column, 10th column, and so on, so that you have to do some kind of selection of the columns, sub-selection of the data points, and so on. You might also like to do some basic visualizations to understand the pattern between your columns. You might be drawing some informations between how is column A related to column B, what is the correlation between these columns, how are your data points relating, and all that stuff. So you would do all these kind of information where you're trying to do that database mapping. And once the data is mapped properly, then what you do is you try to perform this exploratory data analysis. Exploratory data analysis involves a lot of transformation techniques. You would do a lot of data pre-processing. If at all there is some missing value in your information, you try to do missing value imputation. That means that you have to fill up some missing values. Machine learning or deep learning models, whatever we try to see, they do not like missing values. They need to fill the missing values. So you try to do something called as missing value imputation. Then you would also do some conversion. For example, you try to convert the data from um, your categorical to numerical. It is called as encoding. You try to do something called as scaling. You try to do standard scaler or min-max scaler. Multiple other scaling techniques are there where you try to convert the scope of data from one data points to another data points. So exploratory data analysis on the bottom line is nothing but all the pre-processing, whatever you try to do on your data to make sure that your data does not have any garbage. Okay, so why you want to remove all the garbage and unnecessary things and all of that? The reason is because you don't want to have you don't want to have that garbage information given to your model, because if you give garbage information to your model, you will receive garbage outputs. All right, as simple as that. When you give garbage to your when you're giving garbage to your model, you receive garbage outputs. So what you don't want to do is you want to remove any unwanted garbage before you are feeding that to the model. So that will be done in this exploratory data analysis. You will try to explore entire information, identify what is important, what is value added, what is non-value added, and will remove unwanted information from that. You will also do a lot of pre-processing, missing value imputation, scaling, standardization, normalization. Different other techniques will be done here. We would be using tools like NumPy, Pandas, Matplotlib, Seaborn. So there are plenty of tools in the space of data science which will be used here to perform this entire analysis. Got it? So once this exploratory data analysis is done, what you do is you will then feed the data to the modeling section. Now, once the exploratory data analysis is done, you feed the data, and this is clean data. Okay, So you're performing the cleaning or everything. Now this is a very tough task. In fact, a lot of time of the data analysis happens here. You would spend a lot of time doing exploratory data analysis. You'll try to find out what columns are important, what columns are not important. There are a lot of methods and techniques for identifying that information. So you would spend a lot of time here. Then you feed the data to the modeling, and then you have a clean data for your modeling. Now, what is modeling? Modeling is nothing but you could do machine learning or deep learning or any other machine learning or deep learning or any statistical. Let me remove this off. ML or DL. Machine learning or deep learning. So modeling is nothing but you apply your machine learning model or a deep learning model or any other statistical model in which you are trying to understand the relation between your input data and your output data. Got it? You're trying to find out this relation between input and output data, and then based on the relation, you are trying to give this kind of a output result, right? So you're trying to find out this relation, and then based on the relation, you're trying to extrapolate what could happen. You could do prediction, you could do current analysis, you could do descriptive analysis, and different types of analysis could be done in the modeling. And this modeling is an iterative process. So this is not a one step process. This is an iterative process. So you're trying to run multiple iterations till you get the best amount of accuracy. So we call it as accuracy. It is one kind of a metric in which you're trying to see like how your model is performing. So you will run the analysis in an iterative mode for many times till you get the best amount of accuracy. So in this modeling, you will use plenty of algorithms, like you would use random forest. I'm writing some of them, because of the space constraint. So random forest, support vector machine, XGBoost, decision trees, or KNN, your K-means clustering. So likewise, you have plenty of models which will be run in the space of classification, clustering, and you would also run regression analysis. Okay, so here itself, there are like 20-30 different models which will be used for different scenarios. So whenever I identifying classification problems, you would like to go and apply some classification models. Within the classification models also, your data, whether that could be, your data could be very much complicated, your complicated data, or it is a simple data. If it is a simple data, then you can go for simple models, and you can use the simple models for analyzing your output. If it is a complicated data, it is having so much of an overlap and involvement is there. In such kind of cases, we would only use basic data, right? You're getting it? So such kind of applications can be such kind of models can be used. So you have random forest, support vector machine, XGBoost, decision trees, K-means clustering, hierarchical clustering, DV scan, regression analysis. Within the regression analysis, you would do linear regression, multilinear regression, lasso regression, ridge regression, support vector regression, random forest regression. So if I go and talk, you would be getting 100 different model names, which will overwhelm your thought. But just take it with a pinch of salt and just understand that there are so many models which are available for analyzing your data, and different models have different purpose. So some of them would be predicting what will be the categorical output. Some of them will be predicting a numerical output. Some of them will create groupings based on the pattern, and so on. right? So whatever we are seeing here is we're creating this modeling. So this is the meat of your entire data science process, where you apply your statistical technique to identify the similarities of the data, to identify the relation between input and output, and then you create your output modeling. Got it? So once the modeling is done, then what you do is you try to you try to do something called as the model deployment. Okay, now the models are created. For example, an output model is created, which is like an executable, and this executable we need to provide some input so that it will do the prediction and then provide us the output. All right, so this executable, we would need to run it and then see how your model is performing, correct? So this executable, you need to deploy it onto some of your cloud providers and so on. So what you again do is you will do a deployment into now you try to do a deployment into an AWS. I'm just taking AWS for now. You try to deploy this model into an AWS, and then you create an API of the model. Now, what is an API? It is called as Application Programming Interface, which will have all the nuts and bolts for accessing the model, for doing prediction with the model, and so on. So when you're doing this, you might need to use something like a Flask. You might need to use something like Docker, and so on, right? So where you're taking the model, whatever is created in the modeling section, and then you are doing this deployment into your cloud. Why are you doing deployment? We are doing this deployment because this model now has to be served to many customers as a real-time model. For example, for ICICI Bank, you have created a new loan application process, in which customers can go to this ICICI.com slash home loan slash apply. There is a website where they can directly go there and they can key in their information, like what is his name, mobile number, age, marital status, the salary he's getting, the spending patterns, whether he has any available loans or not. So all those things, information about the customer, he will fill in that application and then say apply for loan. When he click the button apply for loan, the application will invoke this API and then feed all the information and then get back the result. Okay, so you would have a front end, you would have an application where user will enter name, user will enter some other information like that. You'll have plenty of informations where the user will enter and then he will click a submit button. So when he clicks the submit button, what happens? The application will invoke. Now this is a two-way process. The application will invoke your cloud provider, the API endpoint which is deployed on the cloud. So it will invoke that API and then it will retrieve that information. So it will do the predictions. So imagine the customer enter the salary, bonus he's getting, yearly increment, and the spending patterns, like for the past 6 months, whatever he's doing, regular groceries, gas bill, current bill, and different other things. All those things will be considered, and then based on all the things, the application, whatever we have created, the model will estimate whether the person will be eligible for loan or eligible for loan or not. And if he is eligible for the loan, what is the loan amount for which he is eligible, right? So imagine he is eligible for loan, so he will get another screen saying that congratulations, you are eligible for 10 lakhs loan or 5 lakhs 50,000 or whatever, right? So that loan amount you are eligible for. So he will get an and in the next screen he will get like a congratulations email. If he is not eligible for the loan, he will say that unfortunately your application is not matching to our criteria. Please visit our home branch for further analysis, for giving much more information about how much is the loan ability, right? So that is what it will happen in this thing. So this one is called as inference, the process in which you're trying to access your applications, and then you're trying to access these APIs, and then you're trying to invoke this front-end systems. This process is called as inference. Understood? And this happens in an online mode. Inference is happening in the online mode. There can be the place where you can also do this inference in the batch mode. Okay, so inference can also happen in the batch mode, where you have the same model. The model is like an executable. Okay, we are just thinking executable. You're creating an API, model, and this one is also on AWS cloud, but it is in the batch mode. And in the batch inference, what you do is, instead of giving a front-end system where we can invoke the model online, you would give a file-based systems processing. So you would have an input file. Input file will be fed to the model in a batch mode. Maybe this job is running in the night at 12 o'clock, and then it will run for an hour, and then it will create an output file with all our predictions. Now, what will be the input file will have? Imagine the bank guys got some 1,000 applications, online applications. So they will collect all the information of the online applications. So online application is just to fill that information. People are already filling, and then by the end of the day, they got 1,000 applications. So the 1,000 applications will be fed to the model in the night. Say by 12 o'clock or 1 o'clock, there is a job scheduled. What it will do is, it will take all the information of the 1,000 applications, and then it will feed to the model at once. So for all the 1,000 applications, you would get an output result in the same Excel sheet, right? So you would get another Excel sheet, output. Now output is nothing but your result. Input is your input Excel sheet, which is fed to the model, and output is the output Excel sheet, where you're getting the output of your model, and that model will be using for your analysis. There is another similar process which is also important, which is used for doing visualization. So there is data visualization. All right, now what is data visualization? You would like to create some reports, you are creating some charts, graphs, and so on, right? So you're creating some reports, you're creating some charts, you're creating some graphs. So all those things can be used for analyzing your data. Now this is called as data visualization. So we are visualizing your data. You would use tools like Tableau, Power BI, ClickView, Matplotlib, Seaborn, the different tools available. So you're using all these tools for performing this data visualization on the result of the modeling. Modeling will tell some kind of relation, some explanation it is able to give. So that explanation you would like to analyze. Analyze in terms of graphs or charts, or analyze in terms of some kind of relation between your data points, so that you can use that information for explaining to your higher up officials. So here you could also use something like this, data visualization and so on. Got it? So this is the entire scope. So now I have created a full page full of explanation in which we are trying to understand end to end, right from where the data is ingested till the data analysis and so on. So the first portion of your data ingestion, the processing, storing, and all those things will be falling into something called as data engineering. Data engineering is where you're having all this process, you're using this for your analysis. That is called as data engineering. The next one, after data engineering, wherever you're doing this exploratory data analysis, the modeling, the deployment, all this falls under data science. Okay, the exploratory data analysis, the modeling part, deployments, all this falls under the data and data science part, where data scientists will be there, junior data scientists, senior data scientists, different job roles will be there. So they will be responsible for taking the data from the data lake and then performing their data science tasks. Data analysis tasks will be performed, where they take the data from this data lakes and then they do the data analysis. That is what you would be using in the data science part. Now the data visualization is a small tool set. So you can say like data engineering, data science, and data visualization. These are the three important key components in the entire data science life cycle. Now, data science also involves the inference like model building, deployment, and inference, both online and batch mode. Now, people who are only concentrating on this areas, they are called as machine learning engineers. So you might see in some job portals about different job, portals and so on. You would be getting different roles. So there will be a data scientist role, there will be a junior data scientist role, there will be a machine learning engineer role. These are some of the commonly used roles. And a machine learning engineer is somebody who is having an ability to build a model, but he or she will be more concentrated on the deployment, API creation, and using the integration between other systems. See, all those things which are required for ensuring the jobs to run, or whether required for ensuring the online inference to run, all those things will be done by somebody called as a machine learning engineer. Now, apart from regular data science, he also needs to understand, how to create these applications. He might need to create APIs or maybe create some endpoints in some other manner. He might need to, also create some of the front-end systems if required. He or she might need to create some front-end systems and use it for the prediction or inference. So that is the role of a machine learning engineer. Now, what is the role of data scientist? Now, data scientist is the heart of the application process. He will be doing data collection from the data lakes, performing all the pre-processing steps in exploratory data analysis, applying all the models, doing fine-tuning of the models, ensuring that they are getting better accuracy, and then doing some part of deployment. He might want to create some APIs and use them for some deployment. Right. So the middle section, whatever we are seeing, is the primary job responsibility of the data scientist. Now, if you would like to ask a question like, if somebody from a data background, where does, what is the good starting point for such kind of people? Now, if there is a fresher, what is the good starting point? If somebody who has 10 years of experience in, programming, using in other languages like Java or .NET, what is the best approach? right? Where they need to start. So somebody who is starting fresh, like who has some knowledge of basic programming and doing something, the best role for them to join is the machine learning engineer role, right? There are a lot of roles available and a lot of job opportunities available. The machine learning engineer is the job opportunity which he or she needs to concentrate. So which does not require a lot of modeling and lot of data science related work. They would need to do some part of work, but they will be able to penetrate into the team. So it is coming from the behind, right? So it is basically doing all the deployment work, doing the Flask related work, Docker related work, creating APIs, doing the endpoints, inferences, and all that thing, and also doing some basic modeling. So such kind of things can be done by the machine learning engineer. Now somebody who is coming from a database background or who already have some data warehousing experience, they should tackle the data engineering part. Okay, so the data engineering which involves in feeding of the data, for example, from some of the tools like Kafka, or Scoop or Flume, and feeding the data, creating the data lakes, ensuring the storage is there, ensuring the file systems are continuously available. So all that work which involves in this first section, so it's a good way to start that, because they are aware about what is an ETL process, how the loading happens, how the transformation happens, what kind of transformations will be happening. All those things they will be very well aware. So somebody who is from a data warehousing background, or somebody who has a database background, who has already worked on file systems, mergings, SQL queries and all of that, they will be fitting in the first section, which is the data engineering section. And slowly, once they start this, they can navigate into the second sections like exploratory data analysis, data modeling, and then eventually they can become data scientist. Now, somebody who is already done some data warehousing and all, they already did understanding of the big data or any of the systems, they already worked on some of the things, they can directly jump into the data science part where they can apply the models, apply the modeling, and then they can purely aim at jobs like junior data scientist, senior data scientist, and so on. Now, somebody from a testing background, it depends whether it is a database related testing or an application related testing. Depending upon those things, whether they will be concentrating on the, using the data engineering and then getting into the data science, or if they're from a front-end testing, application development, they know a little bit of Java, then for them, a machine learning role will be a better one. So there is no one size fit all answer, because it is very difficult, right? So there will be a lot of things, lot of permutation combinations can be formed depending upon our skill, expertise, number of years of experience, and all that stuff. So, but these are some of the job roles which are very commonly used. Okay, a data engineer, Hadoop developer, AWS storage. Hello, you're able to hear me? Got it. So such kind of applications are used, and we will be using such kind of things. Are you following? Any questions so far? I think we almost spent like what, more than an hour? Yeah. Are you following this?
Yes. Hello, Setaram.
Yeah.
My name is Naga. I'm just want to ask you a question. I'm from Melbourne.
Okay.
Here I found a lot of opportunities on data analytics. The job it says only data analyst. So based on that, where do I can fit in this whole diagram, like end-to-end diagram?
Correct. Data analysis is the first process, like when I told, right, where you will be doing your queries on the databases and file-based operations. So you would be loading some CSV files, Excel files, and all of that. So data analyst is like, you can say, like a subset of what data science work will be. So doing related to queries, SQL based jobs, and so on. And slowly they will be penetrating into the data science part, where they apply some predictive models, some of the models, not everything. So most of the work by data analyst will be descriptive data analysis, where they want to describe what is already happening, right? So they can run some SQL queries, identify some result, do some grouping, merging, and so on. But they will be slowly penetrating into some part of the machine learning work. But that is that work is this part. The first thing we understood, right? I hope you're there from the starting. It's the first thing I was trying to talk about. Data will be loaded into the databases. They will run some queries and so on. So that is the actual job role of a data analyst.
Okay. So do you recommend for a beginners this, like data analytics?
Yeah. Beginners, if you see fewer years of experience, freshers, or for such kind of people, data analyst is a entry level role. But generally, the pay for the role will also be less. They are like entry level roles. So the pay related would also be less when compared to the data science and other things. So you need to see like which is the exact fit for your years of experience and your domain expertise and other things. You need to identify which is the best one.
Okay, thank you.
Any other questions in this entire this thing?
Sitaram, in the case of modeling, in the machine learning and deep learning part, so can we use existing models, or can we create our own custom models and libraries?
That depends upon what type of work we are doing. So most of the business applications do not create new models, because their primary purpose is to use the best used models and then try to solve a business problem. So the focus is more on solving rather than recreation. But there are also companies who have innovation wings and divisions who are trying to solve cutting edge problems, trying to create newer innovations, creating newer models. So if you are in that innovation team or research team or center of excellence team, so such kind of teams will be working on creating new models. But if you are customer facing, if you're into a product company who is developing a product, a new product is being created, then primary focus would be using the existing models, like the best used models, best preferred models, and then using them for your analysis. Again, from an
Okay.
academic perspective, yeah, so again, from an academics perspective also, we try to see that there is a lot of emphasis on creation of new models, improving the previous models. So such kind of things can be done from an academics standpoint also.
Okay. Is artificial intelligence also come under this modeling part?
Yes, artificial intelligence,
Okay.
machine learning, deep learning, all those things will be a part of that.
Okay.
Okay.
Sitaram, this is Prabhakar. I have a question about exploratory data analysis side. So you're saying that we'll be collecting the data, like data sets from the data lake, and once we cleanse the data, then it will be ingested into the model, right? For doing the training and tuning of the model. So my question here is that does exploratory data analysis require some volume of data, or can we say that it should be at least of 1 million transactions, or 500,000 transactions? Like what size of the input need to be required for a model to get it tuned?
Basically, we are not really really constrained about the sizes. There are no hard and fast rules that, okay, this is the size which is required for modeling or exploration to be done. If you have less number of data records, what you will see is you would not get good amount of accuracy, only that part. Okay, so the bottom line, we would try to get as much of data as possible, whatever is possible from the business. So we will ask the businesses, please provide all the information, whatever you have, maybe 2 years data, 3 years data, 5 years data, whether that could be in millions or even a couple of terabytes of information. So we will primarily ask that kind of a question. We are not focusing on saying that we don't have this kind of a limits, like only if it is greater than this much of data we have to do data analysis or exploratory data analysis, or nothing like that. But as we understand that if at all your data is less, you might not be able to do so much of an exploration, you might not be able to get all the variations. So the focus would be to collect as much amount of data and then feed that to the EDA, exploratory data analysis.
Okay, okay. Let's imagine a scenario like there is a startup company and they don't have data for the existing customers or any prospects, right? So how does these kind of startup companies can eventually invest in data science or modeling of things?
Yeah, that is a tough problem. So what they do is there are these information aggregators, or so in Amazon there is something called as Amazon Mechanical Turk. So you can create processes or you can create data collection systems where people are will be helping us to collect information. So there are a lot of companies who will sell data, right? Selling data, the company like Experian, which will be selling information. It could be user information, their behavioral patterns, their spending patterns, or some kind of geographic, demographic based information. So all such informations will be sold. There are a lot of third parties. One of the popular one which I know is Experian, which does this work, right? So where they have to buy the data from them, or they can use some of the Mechanical Turk based things where they can create a requirement, and people across the world can work on the Amazon Mechanical Turk. They will be doing the annotations, identifying images. For example, I want to identify differences between whether the person is wearing mask or not. Okay, so now I don't have any data of all the people wearing masks, or people differentiating the images which are wearing mask and not wearing mask. Now how does a person do it? Now somebody has to sit for say 10 days, 20 days, 100 days, and identify all the images with the people wearing masks and with people not wearing masks, right? So that becomes a very huge problem, a data collection problem. So what companies do is they try to outsource that work. So instead of one person sitting and doing it, when they outsource using the outsourcing platforms like Amazon Mechanical Turk, there is AWS Ground Truth and other kind of systems where they can do this kind of annotation and data creation, and people will be annotating it, saying that okay, this part is masked, this picture is not having masks, and so on. And instead of one person doing, there will be thousands of people doing, and you would collect huge amount of information within a small duration of time. In fact, there are multiple approaches, but primary focus is to collect data, whether you buy it or whether you use some kind of known systems where you collect the data. That is how it is done.
Okay, perfect. Thanks, Sitaram. And one last question I have is, so for when we create these models, right, does these models will be fed with only the structured data or unstructured data, or it can be of any kind of data, like because we are ingesting the data from the data lake, which has different flavors of the data, right? So will the model should be a structured data should be fed to the model, or it can be any type of?
Generally, it recommends to have a structure. So when we do the exploratory data analysis, we try to convert your entire data into some meaningful format. So even the images, videos, all those things can be converted into a structured format. But nowadays, with the advancements of deep learning and other things, we don't have to do all that pre-processing and feature engineering and all that stuff. So you can provide your direct raw values to the model, where it will internally do the conversions, it will internally do the understanding of the structure, and then it will produce your output. So, so bottom line, we can provide data as it is, like log information, text files, images, videos, like as it is, instead of converting into a structured format. Olden days, people used to do that, but nowadays with some of the advancements in the technology, we can directly feed these unstructured data as well.
Got it. Thank you so much.
Any other questions? Is analyzing the algorithms or doing coding as per that suits for our solution is hard in machine learning? It's not very hard. Believe me, it is very easy. Or you need to have that edge of analytics, or you need to have that understanding of uh, pattern recognition, analytical skill set and so on, but it is not very hard. And nowadays there are a lot of tools which are emerging. Yesterday we had a discussion that a lot of these cloud providers are coming with these tools. So can we directly use the tools and go ahead and doing it? For some of the problems, you can directly use the tools because they are fine-tuned. You can directly apply a tool. It could be a click of a button, select the model, ingest the data, do a click of a button to do exploratory data analysis, and then it will identify the columns, select only those columns, and then feed it to your model. A model can be a on the off-the-shelf model like random forest, support vector machine, which is pre-tuned. Then I can apply the model and then it will get me the results. So we could do like that. So it is not really hard, and as and when we're going deeper and deeper, it is getting even more easier and easier. If you're doing a lot of research, like if you are in a wing where you're trying to do research, trying to create new systems which will do a lot of newer advancements, and that will create problems, but definitely not here. So you want to create a model system which will when speaking in Telugu, it should convert in say Tamil and so on, right? So that is a difficult model where you really need to have data, you need to do a lot of fine tuning, training and so on, because this system which can do this kind of a conversion will be definitely a very good thing, because now I can deploy that system across pan India, and where I can have multiple different languages, and somebody speaking in Telugu can be converted into Marathi or Tamil or Gujarati or some other language, right? So it's a big problem. But if you're solving such kind of problems, you will require a lot of coding, a lot of analysis and so on. But regular business problems does not require so much of this thing. Got it? Any other questions?
So, quick question. So, if the data mining and data visualization, they're both gonna come into the data science, or are they gonna come into data analytics, or it's gonna be all over?
Yeah, it's all over. So you can give different names to it. But if you're seeing some, like if there was a question like if it's a small startup, right? A person who is working in a startup, he or she needs to work on everything. So he will be doing data engineering, he'll be doing data science related work, visualization, modeling, deployment, both online batch-based modeling. So all purpose person, right? So because depending upon the requirement, and if you are seeing a bigger service company or a startup company, right? Service company which is serving for a specific client. So he or that company might have a different types of job roles created. So you'll have data scientists separate, you have data analysts separate, and their jobs and responsibilities will be separate. And we will be having a different division of data science, and data analytics will be separate. We'll be having Tableau engineers or Power BI engineers who will be doing a separate work, right? So as a depends upon the way of job. It is all together, I would say. It is all linked, very heavily linked. But depending upon how and what job is being done, and which companies do it and how they do it, they clearly demarcate your work.
Thank you.
So there is a question that where the Python plays a key role in data science. So I think the question is like, where is the Python being used here? So as you see, a lot of things are being done, right from the data ingestion till the data deployment or deployment of the model, inference, and all that stuff. Everything you can use Python. You can use Python for exploratory data analysis. There are tools like NumPy, Pandas, Matplotlib, and so on. Machine learning modeling, you could do it with Python, creating all the models, deploying the models using Flask-based applications, creating APIs using it. All that stuff you could use Python. In fact, also you could do visualizations like Matplotlib, Seaborn. There are plenty of libraries used in Python for doing each and every step of this entire life cycle. So it is ubiquitous everywhere.
So what library particularly for the next training section you will introduce, like only NumPy and any other packages that you're going to introduce in that particular?
So in the training, because it is not one set process, right? So what we do is we start understanding the data science and application areas. Then we will get into mathematics for data science. We will also understand about statistics. And then we get into the Python for data science, where we will be understanding the tools required for doing this entire work. Like we would require NumPy, we would require Pandas, we would require scikit-learn, deep learning libraries like TensorFlow, Keras, PyTorch. So you will need to know all these libraries. So we will introduce one at a time, right? So yeah, once we get comfortable, then you go deeper and do.
So when you said statistics knowledge, how much stats knowledge do we need? Like the basic knowledge, or do we go deeper into the in the training?
Yeah, so basic knowledge is required, minimally required for doing data science, right? You need to understand what you're doing, what do you mean by normal distribution, now how you analyze your data, how do you find out different distribution patterns, how do you understand the centrality measures of spread, different dispersion measures, doing descriptive and inferential statistics, how do you do sampling techniques, how do you ensure the sampling is proper and not. So there are some real important statistical things which you need to understand, where you'll be understanding all those things, beyond which, solving some of the statistical models or creating statistical models is required whenever you're doing any research oriented stuff. So for pure data science, you would require a basic understanding of statistics, without which also people will say that, okay, statistics is not required. You can directly get into building a model using an AWS thing. or maybe off-the-shelf models, then what happens is you will be missing that big picture. So you'll be getting your answer, but you will be missing that big picture, understanding like why this happened, what was the reasoning behind it, and all that stuff. In fact, the same is the case for mathematics also. In mathematics, one needs to understand about linear algebra, calculus, the importance of probability. All those things are important. If you don't know, it will still work, but you will be missing that big picture. So you really don't know like what is happening. It's more like a black box.
In that case, it's going to be hard, isn't it? I mean, when you're working in real world, you need to know. So you saying that if you have that knowledge before taking the data science course will be helpful, or do you think we should have that knowledge a little bit and then get into the course is much more helpful?
Yeah, so once you need to have that basic knowledge, right? Of course, everybody has, I'm sure in the +2 or 10th standard or even before, we might have learned these statistical things, or we have learned about the linear algebra and other stuff, but we might have forgotten. We need to have some kind of brush up or something like that, so that we understand like what is happening, how the model is being building. So whenever the modeling is being learned, you would be learning about the mathematical angle of it, like why and this model is working so and so. So that the explainability, I was talking about this explainability in yesterday's class, that we should be able to explain like what is happening and what are the key components of the decision making. So that could be done when you are understanding the algorithms behind it. So that is the reason we would need to go. Even businesses are focusing in that explainability right now, because we need to clearly know that why is this model predicting this answer, right? If you don't know it, you're purely behaving based on the model. You really don't know whether that is correct or it is incorrect. So that is the reason we need to get into the explainability part of it. Understood?
Yes, thank you.
Any other questions? We will take a small break here. Maybe we'll take a 10-minute break and then we will reconvene. All right. Any questions before we break for a small break? Are you guys following? Is it too much to ingest in a 1 hour session? I hope I am making it sound simple. I hope.
No, it's clear. Thank you.
Okay, great. So we'll take a small break here. We will understand about some more important things. I would maybe like walk you through what are the important things which are required for understanding or doing an end-to-end data science course or understanding. So we'll look at some of those things and then we will take it forward. All right. We'll take a 10-minute break here and then we'll come back. Please
Sounds
don't
great.
go up. Yeah. All right, friends, thanks for waiting. Let us come back. We will understand the second part of the session. We'll discuss about, what are the important points which need to be covered, what are the important areas of applications. Those things we will cover, because a couple of people were asking me like what will be the content, how it would be, how will be the course and other things. So I thought, like, why not we'll discuss about the areas to be covered. That will help you because you're already in this journey, so it will help you to understand uh, like what should be the path. So there is a question before I go for that. There is a question like, how about R? Like R is another very important language for doing data analysis, data science related work. But when you are comparing R and Python, R used to be very popular back in 2010, 2012, that time frame, even 2014 also. It used to be very popular. It is a very nice statistical programming language for doing basic statistics, doing POCs and all that stuff. But as Python has grown in popularity, what has happened is Python has come up with all these external peripherals or connecting things, right? So for example, in this particular thing, if I want to have a connectivity with a front-end system, now this front-end system can also be developed in Python. The API can be developed in Python. The integration can be developed in Python. We can have model deployment, where you can move the code, do the scripting and all. All that thing could be done in Python. Visualization can be done in Python. And as you are seeing, all those things, when you're connecting peripherals of the external systems, all those systems can also be coded in Python. When you're getting such kind of an advantage, R is having little problem in that, right? So R is not having that full connectivity, and because of that one single point, R has taken a back step. Provided R was having a good external systems, connectivity to cloud, doing scripting, doing automation, and doing model deployment, or creating front-end web applications or a mobile app. If such kind of things, if R also have the same kind of building ability, then R would have taken in the advantage. But because of the recent advancements, even bigger corporates, right? Even bigger corporates like Google and Facebook and all of that, they are also using they are also using Python as their primary language, and all these frameworks like TensorFlow, PyTorch, and all those things are primarily focused on this thing, Python, and that's the reason that is better than R. And even in our course, we are also focusing on Python because of this sole reason. Because we would like to create, we would like to use a technology which is futuristic in nature, where we are thinking that this is going to stay here for a long time, right? Rather than using for just few months or years, and then after that we have to learn another language. It will be difficult, right? So that is the reason we are trying to focus on learning a technology which is here to stay for a longer duration of time, and we could use it for our analysis. Got it? Any other questions on that front? So learning R along with Python, will it be useful? Yes, certainly it will be useful. When you complete learning Python, right, R is almost similar. So for example, when I'm building a model, I need to provide hyperparameters. The only thing which will change is the syntactical way. So in the syntactical way, you're creating R. So R syntax is little different than the Python syntax. So it will be very easy, and many of my students also done that. It is very easy to adopt to R when you have already done, and when you have a very good understanding of Python, how the projects will be done in Python, all those things, you would be easily able to navigate to R. That's not very difficult. Understood?
Sitaram, I have one doubt.
Yes. Go ahead, please.
Data engineer will provide the clean data, or is it the responsible for the data analyst to provide the clean data?
Now, the job responsibility can be taken by either data engineer or the data scientist. There is no hard and fast rule again there. Some of the data engineers will also do the transformations. So they will do the transformation, and the transformed data will be placed in data lakes. In some companies, what they do is they are only responsible for doing data ingestion and ensuring that they are completely available for analysis and so on. So they will dump the data into data lakes, and the data will be there, raw data will be there. The second one is more preferred, because data science, we don't know which data will be used when. So instead of pre-processing and loading, the ETL process is changed to something called as ELT, extract, load, and transform. So the loading happens first. So in data lake, we will load all the raw data, and later we will try to do some pre-processing, as if like you're dumping all, for example, you're preparing for some exam, say like GRE or some GATE or some exam. First you will try to dump all the questions, right? Then you will try to search in that, like what is important for you, and then you will only prepare those things, correct? So that is what is happening. So mostly in ETL process, the transformation happens and then the load happens. But in this particular scenario, what we do is we do ELT, extract, load, and transform. So the loading part will be done by data engineers, and after that the transformation will be taken care by the data science.
Okay, thanks.
So there are some other tools. For example, there is one popular tool called as Apache Spark, which is used in the data engineering space for Hadoop and other things. And we can do the data transformation using Apache Spark. And in fact, we can also apply machine learning modelings also on big data systems and so on. So people who are having the data engineering experience, who will be doing this transformation, will be using that language for providing the data transformations, doing some small basic modeling and so on. Okay, so let us discuss about this entire course curriculum and all that stuff. So initially it would be starting with the foundations of data science. So we will be understanding what are the important components of data science. We will be understanding about introduction to data science. So whatever we are doing in this workshop is part of this. We will have a high level overview of data science, artificial intelligence, machine learning, the approaches of machine learning. This is a little advanced topic. Different terminologies, understanding the pipeline. So this is what was today's topic, right? We were discussing this entire stuff. So there are a couple more sessions, but after that, we would be completing the first module. So this entire course would be divided into 16 modules, and we would be doing 20 or more projects in that. So first module will be talking about the foundations. We would need to understand the basics or basic understanding. Once we understand that, then we will get into the mathematics for data science. The mathematics required for data science, model building, machine learning, artificial intelligence. So here we will discuss all the important topics which will be required. So in this particular days, we will be scratching our brains to go back to our school age, where we have learned about linear algebra, matrices, matrix operations, eigenvalues, eigenvectors. So what are scalars, vectors, tensors, probability, in probability again, prior, posterior, conditional probability. In calculus, we would be understanding differentiation, gradients, and cost functions, and how they will be solving the differentiations using different formulas and so on. So mathematics is very, very important in this space, as we discussed before a break, that this gives us a clear understanding of how the algorithm is written, right? So if you don't know like how the algorithm is written, what is it trying to optimize, and how is it giving output results, it becomes very difficult for somebody to explain like what is happening, because it will become a black box. We don't know like what is happening, and it has given the results, so we will not be able to explain the output. So that is the mathematics part of it. After we complete the mathematics, we would be getting into something called as statistics for data science. Now, this is also a very important piece of data science. We would need to understand multiple concepts in this. We have descriptive statistics and inferential statistics. In descriptive statistics, we need to understand what are the different types of data, what are the measures of central tendency like mean, median, and mode. We would also discuss about measures of dispersion, variance, standard deviation, ranges, interquartile ranges, measures of shape, for example, skewness and kurtosis of your distribution, and how you can define your probability distributions. What would be a standard normal distribution looking like? What is a Gaussian distribution? How to create a probability distribution function or a probability mass functions, and so on. See, all those things would be used in something called as descriptive statistics. We are trying to describe what has already happened, and for that we are trying to explain the spread, explain the centrality, explain the skewness, all those things. We would be using this statistics. Once we complete the statistics, we will get into something called as inferential statistics. Inferential statistics is talking about something like sampling, inference. You would be doing some testing like hypothesis testing. We will understand about null and alternate hypothesis. You would identify what is the error, what are the different types of error, how do you evaluate the test metrics for those hypotheses. You will try to do one-sided test, two-sided test. You have a chi-square test, t-test, analysis of variance. You will identify the values like t-value, p-value, identify the confidence intervals. See, all these things will be used in inferential statistics. Inferential statistics will help you to understand all these components in great detail. Now, once you complete that part, what you do is you will get into the module 4, where you will be understanding Python for data science. Now, this is the one we are talking about, which will talk about all the libraries which are required for data science. The Python library is required for data science. We will be doing NumPy, Pandas, Matplotlib, Seaborn, Jupyter Notebook, and multiple other things. We would also be doing, within NumPy, you would be understanding how do you create NumPy arrays, different data types, indexing, slicing, creating copies and views, using numerical operations with NumPy, your matrix operations using NumPy, and different aggregation functions, your shape manipulations, your broadcasting, your different statistical operations using NumPy, your resizing of the values, reshape, ravel, and multiple other things will be used here. Next topic would be Pandas. Pandas would be more like a all-purpose tool, right? It is a tool where you would be understanding like how to create data frames, how to do operations, how to do the descriptive statistics, whatever we have discussed, how to do joins, apply, map, indexes, group by, all those things like visualizations, concatenating the data frames. So all the functions which are used in a day-to-day life of a data scientist, that will be done using Pandas. Pandas is a very popular library. It is similar to something like, it is similar to something where we are trying to do our data analysis. So we can do the data analysis using Pandas. All right. So Pandas this is the Python library that provides the utilities and deal with the structured data and all that stuff. So we can also do visualizations with it, but there are specific visualization softwares like Matplotlib and Seaborn. So after we complete pandas, we'll get into the matplotlib. The matplotlib, we will understand the anatomy of the plot. We will understand how to do the basic plot, histogram, scatter plots, how to change the color, shape, and indentations of the plots. How do we display multiple plots? How do you perform box plots, scatter matrix, and so on? All those things will be done by your matplotlib. Coming to the data visualization, you would be using data visualizations like Seaborn and other stuff. So Seaborn and other stuffs would be used for doing data visualizations, where you would be doing basic plotting, like violin plots, box plots, cat plots, spaced grids, SOM plots, pair plots, and so on. We would be using data visualizations using Seaborn. Seaborn is a very rich library for doing colorful plots. Now the matplotlib will be used for doing basic plots, but whenever we want to do some colorful plots and you want to make the plotters brighter, in such cases you would be using this one. Okay, so you would be using something called as Seaborn. So once we complete the Seaborn, we will be getting into the exploratory data analysis. We were talking about that. So exploratory data analysis talks about how do you create your entire data science lifecycle pipeline. How do you do data acquisition, data preparation, cleaning. You would be doing data inputting, reading the data from different text files, CSV files, JSON files. We will be doing data preparation, for example, selection and removals of columns, doing different types of transformation, rescaling, standardization, normalization. You would do binary binary encoding, one-hot encoding, imputing, and train test splitting, and so on. There are different methods of data preparation. This is called as data pre-processing. You would try to do all the pre-processings of your model, and then once this pre-processing is done, you would try to get better output results. The next one is getting into the machine learning part of it. Machine learning is where you will understand about what are the different models which are there, different applications of machine learning, what is supervised machine learning, and within the supervised machine learning, you'll understand what is classification and regression. You would also understand what is unsupervised machine learning, reinforcement learning, different advancements of machine learning, model representation and evaluation, different hyperparameter tuning techniques which are used in machine learning models. Predicting and deployment strategies of machine learning models will be understood in this particular section. After you understand the basics of machine learning, we will get into individual individual machine learning models. For example, we will be understanding supervised machine learning classification. In supervised machine learning classification, you would have again 7 to 8 different models: k-nearest neighbors, decision trees, naive Bayes, stochastic gradient descent, random forest, XGBoost, logistic regression. These are some of the models which are in the space of classification. We would also be doing some ensemble methods like bagging, boosting, voting, and so on for creating more better models. We will be doing model tuning. For example, how do you do train test splitting? How do you apply cross validation using K4 cross validation? What is the variance and bias trade-off? What are the L1, L2 norms, and how do you do hyperparameter tuning and grid search tuning, and so on? Next, you will get into something called as supervised machine learning regression. For example, supervised machine learning regression is where we are trying to identify different regression terms, different variants of regression such as lasso regression, ridge regression, multilinear regression, logistic regression, polynomial regression, random forest, support vector machine. So multiple types of regression methods are there where you are using all these different types of regression models. You would also understand how do you do performance measures. For example, how do you calculate absolute error, mean square error, root mean square error. Different types of error metrics would be understood for getting how good your model is. So you would also do fine tuning based on these error metrics. Once we understand the supervised machine learning, both classification and regression, we will get into the unsupervised machine learning models. Unsupervised machine learning, we have k-means clustering, hierarchical clustering, and DV scan in the clustering section. We have association rule mining, market basket analysis, and dimensionality reduction and principal component analysis using in this section. And then we would also learn about something called as natural language processing. In natural language processing, you would have different other natural language processing methods. It will have an ability to understand how to identify the text-based processing. You would be understanding some of the important components of that. For example, you understand what is text analytics, what is stemming, lemmatization, how do you do stop word removal, what is parts of speech tagging, what is name entity recognition, understanding about bigrams, n-grams, and co-locations. You would be performing term document metrics creation, convectorizer, term frequency, and inverse document frequency, TF-IDF we call it as. So all those important models which are responsible for creating applications using natural language processing, we will be understanding that. Once we complete the natural language processing, we'll be getting into the advanced analytics. We will be understanding time series analyses, ARIMA models, content-based recommender systems, collaborative filtering. These are some of the advanced analytical models which will be used for doing more real-time complicated systems. We would also be understanding about reinforcement learning. Now, reinforcement learning is a mechanism in which we will be understanding different basic concepts of reinforcement learning. There is action and reward based mechanism. There is a penalty based mechanism and a feedback loop which will be providing. We will be understanding how all these different systems will be working. Now, once we understand about the reinforcement learning, we'll be getting into the important concept, the artificial intelligence. We will understand like what are the base of the artificial intelligence, the artificial neural networks, how those artificial neural networks work, what are the different terminologies, what is perceptron learning, what is feed-forward network, and what is backpropagation. So there are a lot of terminologies here. Please don't get carried away with all these things. We will be understanding all these things in great detail. Because a lot of ground has to be covered. We would also understand the mathematics required for artificial neural networks. For example, how do you do gradients? How do you apply partial derivatives? Understanding about linear algebra, the vectors, eigenvectors, projections, and so on. All those things will be learned here. Then we'll be getting into the tools required for natural language processing, neural networks like TensorFlow and Keras. We will be learning about them. Then we'll get into the deep learning, which is the heart of neural networks. We'll be understanding how these neural networks are formed. We will understand about multilinear perceptrons. We will understand about convolutional neural networks, recurrent neural networks, autoencoders, and different other deep learning models. We will understand detailed about convolutional neural networks. What is the architecture? How do you do different kernels? You will understand how to build an image classifier using your convolutional neural networks. In the same manner, you would also understand about recurrent neural networks, where you understand how to predict a time series data using recurrent neural networks. We would also create chatbots using RNNs using this model. Now, once, so this entire thing would take almost 3 months, but once I complete this one, we would also understand two important concepts, which is called as cloud computing for data science and DevOps for data science. This is almost ignored topic, because cloud computing for data science is very, very important, where we understand what is cloud computing, what are the different components involved in cloud computing, how do you do big data processing in cloud computing, how do you apply machine learning using Amazon SageMaker, how do you do deep learning on AWS cloud, how do you do natural language processing on AWS cloud, and so on. I have a good experience in AWS, and that's the reason I'm using AWS here. The primary focus of this cloud computing for data science is to understand, now if I build a model, how I will deploy this model onto cloud so that everybody else can view it and then run their modeling on their AWS cloud. Now that is what we will learn in this particular section. Next one is DevOps for data science. DevOps for data science is where they will be understanding different DevOps concepts. For example, introduction to DevOps concepts for data science, different tasks would be there, like how do you do deployments of the models in production, how do we do deployments of model in terms of services and containers, how do you do scalable machine learning models using Kubernetes and so on. All those things we'll be learning in the DevOps part. DevOps is almost like an automation process. Whatever we have seen, the end-to-end life cycle, all that thing can be orchestrated using the DevOps processes. So using the DevOps processes, we will create the systems in such a way that, once the file is there, it will automatically run the job, get the result, take the file to the next system. So you would create this end-to-end automated system so that we don't have to involve in running the jobs, ensuring the accuracy, creating automated systems in terms of error creations and so on. All those things can be done using DevOps. Now this is a lot of thing to digest, and this will also have, as and when, as I told, these are huge amount of topics, and we need to do a project-oriented learning for understanding this. If I don't do a project-oriented learning, if I learn about the technology and algorithm and so on, it will be very nice to hear, but whenever you get into the real project coding and work, you will face a lot of problems. So to solve that, what I've done in the curriculum is I've created 20 projects which will be done throughout the course. So those 20 projects will be dealing with each and every algorithm. So whatever algorithm we are learning, we will be doing a mini project along with that. So that project will be solved, and by solving the project, we will be learning about the algorithm. So let me also walk you through some of the projects. So there are 20 projects are there. There is XML to CSV converter for understanding Python. So this will use basic Python. Then we will be creating a photo editor from the scratch using Flask and NumPy. This will help us understand how to build applications using Flask and using a NumPy to create a photo editor. Then we will be getting into exploratory data analysis, where you will be understanding all the exploratory data analysis using retail shop sale data. Here you will be using pandas and matplotlib and seaborn, all the libraries together. You will be creating this project, so you'll understand how you approach a problem by doing exploration. Once this is done, you will be getting into food type prediction, where you will be understanding k nearest neighbor algorithm by predicting different food types. We will be doing with k nearest neighbor algorithm, and then we will be doing another project on predicting malignancies in mammographic masses using decision tree algorithm. We'll be doing a project where you'll be predicting the H1B visa process, like shortlisting an H1B visa process candidate by using a random forest algorithm. So we will be learning the random forest algorithm, and we will do this mini project so that we'll understand that end to end how you apply this algorithm. Likewise, you'll be doing predicting the breast cancer using support vector machine. You'll be doing HR analytics for attrition prediction using logistic regression model. So while I'm learning the logistic regression, I'll understand about the use case about HR analytics, how do they predict attrition, and how to do an end-to-end project for HR analytics. Similarly, we'll do a churn analytics using 10A communication. This is also using multiple models like support vector machine, k nearest neighbors, random forest, logistic regression. All those models will be used in a combination to create a churn analytics, where a person is moving from one provider to another provider. Now, how do I identify such people, and then how do I ensure that those people don't move? Similarly, predicting of house prices using regression, social network ad based analysis using different models. You do retail customer segmentation based models on different spending patterns. Your customer analysis plays a crucial role here for determining the profitability of the company. And here we will be using k-means clustering. We will be doing market basket analysis using a priori algorithm, where you try to understand the associations between the products. We will do SMS spam detection. For example, people send SMS. There are some spam SMS, some good SMS. How do we determine whether this is a spam SMS or a good SMS? This is exactly similar to how our Gmail spam detection works. So we will be doing that using natural language processing. We will be doing sentiment analysis on restaurant reviews on natural language processing. It will be using natural language processing and supervised machine learning. Then we will get into the deep learning part, where we'll be doing image classification using deep learning. And here we'll be doing interesting use cases where we try to identify two top actors, for example, Shah Rukh Khan and Prabhas. We are trying to differentiate, given an image, the model should understand whether that is a image of Shah Rukh Khan or Prabhas. So like that, we have created a model, image classification. We have also created content-based recommender systems using deep learning. We will create chatbots using recurrent neural networks using deep learning. And this one will be a conversational chatbot. So given a lot of conversation data, it will be able to learn from it, and you will be able to chat with that as if you are chatting with a person. So after this, we would also learn about stock market prediction, like using LSTM and ARIMA models. You will do a stock market prediction, how the price will go, whether it will go up or down. We will try to predict that using machine learning models. We would also using exploratory data analysis in crime records using Boston. This is more using exploratory data analysis, using linear regression, XGBoost, and other kind of models for doing the crime detection. So as you are seeing, there are plenty of algorithms and plenty of projects. This is close to 20 projects. We will be doing more than these projects throughout the course, so that it gives a very, very strong foundation on whatever you're trying to learn. Now, whether you're trying to switch jobs, or you want to go to a better project in the data science area, or you are learning it for a knowledge sake, whatever is the requirement, when you do this comprehensive course, you would get a complete understanding of what are the technologies, and they will be backed up with these projects. Because when they are really backed up with these projects, you really understand like how the projects will be done in the real world. The projects are really important. If I talk about the technology, I can talk about technology for hours and hours. I can sit for the entire day and then speak about it, but that will give a good feeling, but it will not give a sense of completion in terms of project. So you have to do hands-on, only then you will be able to do it. So the focus would be once the course is completed, so whoever will be doing the course, they should create a GitHub profile. GitHub is a new resume, so it is more like a portal where you can put all your codes, all code bases, your projects, everything can be posted there, where you would be using that as your resume. So you can have to do at least 4 to 5 projects which are in GitHub, so that whenever we go to any interviews, you should be able to project that, I have done so and so work, I have an understanding of these algorithms, and I would be able to work for your organization. So you should be able to portray that in a nice manner. So that is the focus of the entire course. Got it? I think a couple of people were asking questions regarding the structure and the course and the material and the projects and all. So I think this particular document has given you a good understanding. All right. Any questions on this? Are you able to understand? I know this is too much to ask on a Sunday morning or a Sunday evening or Saturday evening, but I hope you guys are understanding what is the depth of whatever we are trying to understand. So if you want to concentrate on only machine learning, I need to do in your curriculum along with 7, 8, 9 stats and mathematics. Yeah, so if you do some refresher, so in fact, I also give some links of videos and all that stuff, where it will give a very, very nice understanding of these topics. Now, you don't have to go to your 7th standard textbooks. There are plenty of material available online. So you can go through that material and you would be able to do it. If somebody is interested, really, let me put down that link of YouTube. It's called as, the channel name is 3 Blue 1 Brown. Okay, this is the channel name. I hope everybody is able to see it. Okay, module 7, 8, and 9. Yes, so module 7, 8, and 9 you just would require for machine learning. I'm sorry, I was thinking school. I went back to school. So yeah, model 7, 8, and 9 would be required. And then if you do statistics and linear algebra, you would be learning about the machine learning part. Now, if you don't want to concentrate on the deeper components, only you want to concentrate on the machine learning, you can learn till that part. Yes, that's correct. But if you really wanted to understand about linear algebra and so on, the channel name I just put, 3 Blue 1 Brown. That is a very, very good YouTube channel. It's my heart favorite because he will explain the topics in such a lucid manner and with some illustrations, so you will have a good understanding of what the topic is, what it is doing, and all that stuff. So okay, any other questions? I think we have almost spent more than 2 hours, 2.5, I think close to 3 hours. What's the time? I did not check. Yeah, 2.5. So any other questions? Are you guys following? Is it worth my time to explain all these things? I hope you guys are understanding all the topics. I know these are complicated, but I hope you are following it. The pace is okay and everything is fine, right?
Yeah, I think I like the overview of it.
Okay. So any other general questions, if you have, I will be able to answer. We will take a few minutes to answer them. Any questions you have regarding the technical part or anything which you would like to ask, please either post it in the chat window or you can speak up. I think the videos will be recorded and these will be posted in the Kerry Wrighty's YouTube channel, or you will be getting some links. Please go and watch those if you have missed some part of this workshop. And if you have any questions, certainly reach out to the team. Definitely, they're very nice guys. They will be responding to you immediately of any questions you have or any thought process, any details you would require. They will be responding very quickly.
Sitaram, what is the difference between cloud computing and DevOps?
Cloud computing is where I am renting a system. For example, now I don't have a laptop. My laptop is only 4 GB. Okay, 4 GB RAM and say like 100 GB hard disk. But now from my business, I'm getting some 500 GB data. And for running my model on that 500 GB data, I would require at least 16 GB of RAM. Now, what I will say is I'll ask my friend that, can I borrow your system for running my analysis? And then once I'm done with my analysis, I'll give back your system. Okay. So your friend's system is 32 GB RAM and it is having 1 TB hard drive. So it is very good enough for running your analysis. So you'll borrow the system from your friend and then run your analysis and then give it back. The same concept is done in cloud computing. So what we are doing is the big companies, they have huge infrastructures. They are providing infrastructure on rent. So AWS, Google, Microsoft, what they did is, because they have huge amounts of infrastructure, they thought that why can't we rent it out? And they have created websites and then renting out their infrastructure. So imagine my laptop is only 4 GB and I am not able to do bigger processing. What I want to do is I will rent out a system from Amazon. I'll say, okay, I want a VM. Their technical call is, I'm saying system, but technically we call it as virtual machine. Virtual machine, it's not a physical machine, it is a virtual machine on cloud. So virtually I am trying to take that machine and I'm saying that I would need the machine with different configurations. I want 32 GB of RAM, 1 terabyte of hard drive. It should be preloaded with a Linux OS or Ubuntu or Microsoft Windows and so on. And based on these configurations, I will be able to rent it out. The good part is the cloud computing, I can only rent for the duration which I'm requiring. Imagine my job only requires half an hour. So I will only rent it for half an hour and I pay on demand. You're getting? So cloud computing is providing facility in terms of where we can rent the infrastructure, rent your software, rent your entire system, network space and all that stuff. And imagine I want to launch a website. Instead of launching it on my on-premise system, which I need to run it continuously 24/7, web servers, people will call, right, web servers. Instead of taking that web servers, what I'll do is I'll rent it out from cloud. I'll say, okay, go to Amazon, rent out a machine like 1 terabyte hard drive and 16 gigs of RAM, and then that will be continuously running. You will deploy your models or website on that machine so that it will be 24/7. So you don't have to ensure that the power backup is there, the cooling is there, everything is there. All those things you don't have to worry about it. You're just renting a machine on the cloud and everybody else is able to access your system. Now the same thing works for the machine learning and other things also. The models will be deployed in the cloud. People can directly use the models on the cloud. You don't have to worry about that. Now that is cloud computing. DevOps is a process. For example, doing this entire stuff. For example, I say every day in the night, there will be one job which will be running, which will be identifying who should get loans. Okay, you get huge amount of data. We were discussing that use case, right? So huge amount of data will be available. So if I want to create a process which will start in the night, so at 12 o'clock in the morning, early morning, there will be a job which will be running, which will take a file from your cloud storage and then run your model. You'll get some results. That results will be emailed to your email ID, support email ID or some email ID. You will be getting an email. So if you are seeing, this is a multiple things are required here. You have to copy the file, run your model, then email the output result to your email. So I'm just simplifying this. So this entire process would be automated. The entire process is automated by creating some systems. It could be automating the infrastructure, it could be automating the process, software, and ensuring like how these entire systems will be spinned up, right? All those things will be part of your DevOps. Understood?
That's it. I'm understood.
Both are very, very important in this particular era where we are going into a phase where we are going into such a phase where everybody is going towards cloud computing. This becomes very, very important.
Then what is the difference between cloud and cloud native, Sitaram?
Cloud, these are terminologies. That's it. Cloud native is in sense specific to cloud. Okay, that is kind of a terminology which people will be using. Cloud native in sense applicable to cloud, only in the cloud, not like a general application which can be deployed onto the cloud. So such kind of things will be called as cloud native.
Okay. If a business analyst want to move to data science technologies, then in which role he will fit into that one?
Business analyst, I think the best area would be either talking about the becoming a data scientist, junior data scientist, or data engineer. Those are the ones which will be better.
Okay. Thanks, Sitaram.
Any other questions?
So for data engineer, what are the courses that needs to be covered for being a data engineer?
For data engineer, you need to learn about big data. Okay, so data engineer is I would say they are all linked, but that area is different, right? You need to be working as a Hadoop developer or data ingestion engineer. You will be learning about the tools like Kafka, Flume, Scoop, and other things, which are, again, this is a huge gamut of technologies, right? So that itself will take another 2 months of time, technically. So that covers like Spark and machine learning using Spark. There are tools like Hive, Scoop, Pig, and so on. Those things will be learned in the data engineering part. You will need to learn about big data. I think Career IT is also providing very good trainings on big data. If you are focusing on that area, certainly that is the area to learn.
No, like business analyst and how data engineer, how they're connected actually. Like where is the route for the business analyst to become a data engineer? Because business
So
analyst means like he looks at he's a bridge between the business and the development team, right? So
correct.
so does it, are we talking about a specific area, like I'm a business analyst in a specific like analyzing data in a particular domain? So is it how I need to interrelate that? I'm trying to understand actually.
See, if business analyst is kind of, as you rightly said, it's a bridge between your business and the development team and other folks. So he or she is the person who is be really interpreting the understanding of the requirements, what should be done, what not should be done, and then percolating them into a technical requirement. So that is the prime work nature of the business analyst, right? So the topic what we are talking about, data analysis and data science and so on, is more in the technical area where they get the data. Now the business analyst will say that, okay, we would require do this and this, and technical person will know like what tools to apply to get that. So how do you do analysis to get that? So all those things will be done by the data analyst or data engineer, data scientist, and so on. Now, data engineer will be working on ensuring that the data is available, ready, data is ingested properly, and so on. So the first hard work, whatever is required for ensuring the data is ready, that will be done by a data engineer. A data analyst or a data scientist is the one who is looking at the data and then trying to solve the problems what business analyst has given. Like he says that, okay, we want like this, and the data scientist would be solving the problem using algorithms. Got it? That's how it
Yes,
links.
got it. Yeah, thank you.
Right? Any other questions? All right. So thank you very much. I think there is a question in the course. Everything is taught practicals. Yes, as I told that we will be doing project-oriented learning. Right? These projects are there, right? Throughout the course, we'll be doing project-oriented learning. So we'll be using softwares and we'll be using the DevOps and all that stuff. Yes.
So what are the tools we should carry prior to the course? We have any kind of tools we have to carry?
Most of the course would be cloud driven. I would be using a cloud platform called as Google Colab. It's a cloud oriented tool. So you can I would also provide the tools which are required for downloading on our laptops. Like you would require Anaconda, you would require Python and other stuff. But mostly throughout the course we'll be using a cloud platform which just requires your Gmail. And if you just have Gmail, you don't even require a laptop, right? You can you can do the program on mobile also. It's not recommended. We would be using something called as Google Colab, and you would be doing a setup on Google Colab. I will be talking like how to set it up and how to do programs using Google Colab and all that stuff. So it's called as Jupyter Notebook, one widely used data science tool which is used for development. And so Jupyter Notebook, which is deployed on Google Cloud, is called as Google Colab. We will be using that for the entire course. So that does not require you to buy laptops or heavy devices, right? People, I unfortunately I hear this many times that somebody is trying to do some training and then they have recommended to buy a 80K laptop where with all high-end softwares and hardwares, but technically it is not at all required. Nowadays we are having all these cloud providers where we can create few free accounts, and Google Colab is free, so I don't have to pay anything for that, right? So such kind of things are happening, so we don't have to pay even a penny. If you have a basic laptop, say like 4 gigs of RAM, and you're able to do basic things, it's good enough for you to complete this entire training without any other further investment and so on.
Thank you.
Sitaram, will you explain a local machine setup as well?
Explain local machine? Yeah, local machine also will be there, but as I'm saying, I will show like both ways. But mostly our code will be running on the cloud, but I'll be showing like how to do it on the local, because these DevOps and deployment of the models, those all things we will not be able to do it on the cloud. I will be able to learn, run the notebooks and all, but the deployment, creating end-to-end applications, all those things I have to create projects. Now that projects cannot be done on cloud, so we will be doing on the local machine. You got it? You can do it on the cloud, but I have to rent it out, and you have to pay money for that. So I'll be showing that also, but it is not recommended for everybody. So you got it, right?
Yeah, I got it, Sitaram.
Yeah. Great. So any more questions? All right. I know that some people are from US. It is a long weekend out there. Not sure how you are celebrating your long weekend. Listening to me patiently, I really thank from bottom of my heart for patiently listening to me for almost 3 hours, 2 days, Saturday, Sunday. And thank you very much. And I hope to hear to you again. And if you have any questions, please reach out to the Career IT team. They have provided the phone number and the info email. They'll be certainly reaching out to you for any clarifications you might require regarding the workshop or anything regarding the course or something. And I hope to see you again. Thank you very much. And I hope that you liked the sessions and the time is well spent. All right. Thank you and have a nice day, and please do take care of yourselves, stay safe, don't go to beaches or spend your time in a crowded place. Okay, thank you.
Thanks, Sita.
Yeah, thanks, Sitaram.
Thank you.